After all that data transformation, we're ready to pipe together all of our lines of code into one long statement of code that will take us from the data to our visualization. It's fine to have your code in different steps with objects stored along the way, and it's also fine to pipe it all together in one long string like this. Let's walk through what this string is doing. We started out with our CPS data. Remember, this is data that had several variables in a survey recorded for each of 100,000 people. We then restricted to the cases for whom the week's work 2 variable equaled the value 6. Once we did that, we had a data set with only 92,307 cases. We further restricted to those with valid values for the inc wage variable corresponding to incomes. So we now have reduced to a data set with 86,512 observations. We then grouped by year, and for each year we produced 3 summary statistics, the 10th, the 50th, and the 90th percentiles. This is what our data set looks like after we've summarized. Instead of a row corresponding to a person, a row now corresponds to a group defined by year, and our columns are year and then our 3 summary statistics. We then pivoted longer to move these summary statistics into one column called income. I'm going to go ahead and highlight down to here where we have our pivot longer called. We have our calls, P10, P50, and P90, which are the columns to be pivoted. The names of those columns are going to go to the quantity variable and the values to the income variable. Once I run this code, I now have a big long data set with many rows, one row for each year quantity combination, with incomes noted in this next column. Once we've pivoted longer, we next want to join in data for an inflation adjustment. So we read some data from the course website that tell us how many dollars in 2023 terms each dollar was worth if we look back into past years. So we merged in this inflation adjustment factor. So we now have a new column on our data, inflation factor. This was joined in by year because in the data we're joining in, there was one row per year containing the relevant inflation factor. We then applied the inflation adjustment. We took our variable income and we multiplied it by the inflation factor. We then stored that back in the income column. At this point, we were ready to produce our ggplot. So we have the variable that's going on the x-axis, year. We have the variable that's going to be colors in our plot, quantity. We have the variable that's going to be on the y-axis, income. And so we can go ahead and map these in our aesthetic mapping in the ggplot call. Note that I omitted the data argument from ggplot because here we've piped this existing data set down into the ggplot call with our pipe operator. We're going to use a line graph and we're going to make some customizations here that you can read more about on the course website if you'd like. This is where you can play with things to make the plot look however you want. When I run all of this code, we see the plot that we've produced. We have a plot in which we can see that the 90th percentile of annual wage and salary incomes in real 2023 dollars increased substantially over the period of our data, while the 50th and the 10th percentile were relatively flat. We could say that this shows a moderate increase in inequality across this period because the bottom of the distribution stayed relatively flat, whereas the top increased substantially. More importantly, you've now learned how to take survey data, aggregate them, and manipulate them to produce a graph.